Right, it's being sorted. So yes, we just in the Philippines we love our photo opportunities, and we like to commemorate this special moment. So no event in the Philippines goes without photo opportunities, and I
No
guess you'll
worries.
learn.
Even in
Uh,
Korea, it's the same.
oh yes,
Really got photos. Yeah.
yes.
So I'll do the taking. So one, two, three, smile. Thank you. It's done.
All right, thank you so much once again,
Thank you so
Mr. Shin
much.
and Miss Diana.
Thank you very much.
Thank you.
All right. So let's now proceed with our next presentation. Our next presenter is Mr. Wilfredo Pardola Jr. Sir Fred, known by his student as Sir Fred, is a dedicated science educator known. Uh, he began his scientific journey with a diploma in environmental science from Alderson, Ireland, and furthered his studies with units in planetary studies at Arizona State University, USA. He made remarkable strides by co-mentoring the students at St. Cecilia College in Cebu in groundbreaking projects, including the country's first academic institution, weather balloon flight in 2016, and the design of a solid propellant rockets recognized by the Philippine Space Development Program in 2017. He continued to excel, leading the HAB LSS Karunungan Flight Team, securing a national research grant from the Department of Science and Technology in 2018, and representing as a delegate at the International Summer Space School in Russia. Notably, this year marked the successful launch of the Tala hybrid rocket in Tarlac. Presently, Sir Fred is an esteemed educator associate of the American Institute of Aeronautics and Astronautics, a certified Google educator, and is on track to complete his Master of Arts in Educations in Physics teaching at Cebu Technological University. Good morning, Sir Fred. The floor is yours.
Thank you so much for that very generous introduction, sir. Tito. Let me share my screen to everyone. So, part of the presentation here. So we have this one. Okay. So I hope you can see my screen now. So this is about Tala hybrid rocket research with regards to the rocket launch operations. And I am Alfredo K. Pardorla Jr. and I will be representing the Tala hybrid rocket research. So to start, I want to introduce to you the Tala hybrid rocketry team, starting with Christian Lawrence C. Cantos, our team leader and avionics systems lead. Uh, Here we have John Harold R. Barkas, our ground support equipment systems lead, Francis L. Espino, our CAN satellite payload lead, Joshua K. Pardorla, our propulsion systems lead, Jeffrey Manuel T. Kapampangan, our structural systems lead, and Dorothy May Ambon, our recovery and ejection systems lead. And my co-mentor, Miss Almida Clarison, and yours truly, and I will be representing this team. So let us go to the memory lane and check out what's our introductory video in terms of the Tala hybrid rocket to give you the background of this research project with the Department of Science and Technology, Philippine Council for Industry, Energy, and Emerging Technology Research and Development way back 2018. That's a very short video, but it's really packed with much information. We started with our students when they were still in high school, and they were still in grade 8 way back 2017, before we were granted with a research with the Tala Hybrid rocket. So we started with model rockets to celebrate the commemoration or anniversary of the weather balloon that we have launched in 2016. Our first research grant also from the USDP was the high altitude balloon, which is capable of launching up to 3 times the cruising altitude of airplanes. So right on the 2018, we have already got the Tala Hybrid Rocket research grant, which is really great. And the students are really, really happy because they want to scale up from those small solid propellant rockets into hybrid rocket already. So we even wanted to launch it on 2020, but because of the pandemic, we have to launch it on 2023. But we are still very, very happy and very blissful that we have the Philippine Space Agency and the Philippine Air Force which strongly supports us along the way to the launch date. So what's Tala Hybrid Rocket? So it's a cost-effective 10-feet hybrid propellant rocket that has a capability of, or the primary goal of launching and deploying CANSAT as it reaches apogee. So the rocket propellant is hybrid, and our airframe material is a 3D printed carbon fiber composite, which is built in-house in the science laboratory of St. Cecilia's College. So the recovery system is dual deployment, which is the drogue chute also and the main parachute. So we have our successful launch date on May 20, 2023 at Kappa Starla at Curve Valley. So here's the Tala Hybrid rocket and its subsystem. So we started with the avionics subsystems in here, which encompasses the telemetry, which is also the payload and the ejection system, which is connected to the recovery subsystem here. So we move on to the propulsion subsystem, which encompasses the engine. So basically it has propellants, which is our fuel is a solid type, and our oxidizer is liquid. So we also check into our impulse, momentum, and thrust on this rocket. And here is also our structural subsystem, a very important subsystem also because we have to build it right from the tip of the nose cone to the fins of the rocket. And lastly, our recovery subsystem, which is dual deployment, as what I've mentioned earlier. We have for added safety also, and so the recovery range from the point of the launch to the point of the landing is near. So you need to have that dual deployment system. So and the fifth one, which is not included here, is the ground support equipment, which is already also a big thing to talk about later on. So we have here our rocket also with the structural subsystem, which is these are the basic parts. We have the nose cone, the drogue compartment, which is located here at the middle of it. We have the rocket engine and the nose cone. We have the main fins, our canard fins also, and our avionics bay. And then we have also our main compartment in which it encompasses our payload and recovery subsystem. And also we have lastly our propulsion system. So I want to talk also with the highlights, which also signifies our milestones that we've done with the Tala Hybrid rocket. And I want to talk to you with what are the things that we do also behind the scenes before launching this one. So I will start this with a video which was released with the Philippine Air Force for this one. So here we are. We cannot do the launch without these partners that we have, or which is our activity partners for the launch itself. So First, that's the Philippine Space Agency. The next one is the Department of Science and Technology, Philippine Council for Industry, Energy, Emerging Technology, Research and Development. Of course, St. Cecilia's College of Cebu, we're in the mentors work there, and our students from junior high school to senior high school also. So the Philippine Air Force also with their units, multiple units will really support us also throughout the launch. We have the Colonel Ernesto Medina Air Base, the 7th 10th Special Operations Wing. We have the Air Force Research and Development Center. We have Air Force Systems Engineering Office, 950th Cyberspace and Electronic Warfare Wing, our Air Force Public Affairs Office, and the 7th 90th Air Base Groups. So here, the Tala hybrid rocket launch is not just a one-day activity. It's really a one-week activity, which is an umbrella from the Philippine Space Education Tour, also which features the Space Science and Technology exhibit. We have water rocket activity, and lastly the Tala hybrid rocket. So for 1 week, Philippine Space Agency with the different teams, and also with some of the representatives from the Tala hybrid rocket team, went to different schools in Tarlac to spread awareness and information on the things that the Philippine Space Agency and our efforts also to space technology and education. So here while the teams of the Philippine Space Agency went to these schools, we also went to the launch site to do several testings. So here you can see that this is the site wherein we have launched. The site is a very challenging site because it's the site wherein we have the lahar from Mount Pinatubo, and the rock is rich also with silica. So we have to protect our avionics systems that we have tested. And here you can see that there's a makeshift shelter, aka we have a clean room for our avionics systems and other systems that we tested. So we tested right before the rocket launch, because 20 is our launch date, and it's actually a backup launch date. 19 was the original, and then the days before that is our testing. So we have different tests. We have satellite connection test. We have also distance test with our communications with the rocket, and on other systems also with the rocket. So it's not just 1 day operation as to how you launch the rocket. It's several days to make sure that all systems are go, all systems are in optimal condition, so that every step of the rocket launch is nominal. So here we, as our one of our advocacies also is to spread awareness for other Filipino youth, other Filipino students, universities, and we also want to spread as much as possible on that inspiration. And one of that testaments is this TikTok video, which was released by Pinoy Science in collaboration with the Tala Hybrid Rocketry team.
Hi, we are the Tala Hybrid Rocketry team.
Hi guys! In today's hashtag Learn on TikTok, we're going to talk about rocket science. Although there's a difference between hybrid rocket from other rockets, they're governed by the same fundamental laws of motion by Sir Isaac Newton. The third law of motion, or the law of interaction, states that for every action, there's an equal and opposite reaction. It explains the generation of thrust by a rocket engine. The hot excess gases flow to the rocket nozzle and is accelerated to the rear of the rocket. When the thrust is greater than the weight, there's a net external force equal to the thrust minus the weight, and the rocket begins to rise. The 10-feet tall Tala hybrid rocket will produce a maximum thrust of 5,700 newtons. It's enough to accelerate the rocket to the speed of sound in a few seconds. That's the science behind the rocket.
Okay, so that video was spread out to share awareness also by Pinoy Science. It's a page by the UST shirt also. So continuing with the process before the launch, we have here on hours before T0, you can see that the Tala Hybrid Rocket team is very busy. They started at dawn just to set up the rocket in here. So this is one of the very thing that we need be to to really check all subsystems so that we can assure that and we are confident that the rocket it will really be optimal in its condition. So here you can of course see the scale of the rocket with regards to the persons that are present in here. So in the video, it's you might think that it's quite small, but in here you can see the scale of the rocket with regards to the people in here. So here I would also like to share this picture with you. This is one of the behind the scene photos that we have. So you can see binoculars in here, an astronomical telescope, so that we can really assure that the smooth operations with the ground support equipment right during before and after the launch. So you can see here we have the launch controller, which is I will be reiterating later on. So here we have C plus let's say few seconds on the launch. You can see that we have dust and the sand which are escaping from the ground zero of the rocket. That's how powerful it is. You can see, and then this is the time where we really shouted at the top of our voice because we after 5 years of making this one, this rocket really go and escape the launch trip. So here in this picture, you can see that the rocket is now on a very significant altitude and continuing its path through its apogee also. So you can see here one of the very thing that we really hope that would work is our parachute. So it started with the drogue chute that we have on the apogee and predetermined height. We have also our main parachute with our rocket. And you can see in here that it's about to safely land on the Kuro Valley, and right after that, you can say that we have recovered the entire rocket, and that's really successful. So one of the paramounts of the launch operation of the Tala Hybrid rocket is safety. So you can see here it's represented by this picture of fire extinguisher, which is also present on the launch for the Tala Hybrid rocket. The safety margin for the Tala Hybrid rocket is really high compared to the solid ones, the solid propellants, because we can remotely control the operation from 500 feet away. So here you can see there's a safe distance table, which is we got this and from the National Association of Rocketry from the United States of America. You can see that our motor type is actually M, an M plus motor. So we need to be at 500 feet from the launch pad. So here this is assigned to engines, which is the total impulse of 5,120.01 to 10,240 Newton seconds. So here we go beyond with the minimum distance range for the rocket. So you can see there's a launch platform in here, which is the ground zero, which is colored in blue. And there's the red ring, which is the 500 feet or 152.4 meters, which situates our launch controller for ground support equipment lead and propulsion subsystems lead. So, and the rest of the rocket team should be at the 1,500 feet, which is 457.2 meters for this outer ring. And we go beyond for this one on a 1.5 kilometer radius for general audiences and dignitaries from the different government agencies, including the Philippine Space Agency. And then you might wonder how would they see the rocket launch from 1.5 kilometers away from the launch pad, and I will be explaining that here also. And to give you the idea, this is a view from 500 feet perspective on what will you see from the rocket. I will try to zoom it in so that you can see this is an actual rocket. So we have the rocket in here. Try to activate the laser. So we have the rocket in here, and we also have the oxidizer tank at the side of it. So here's the answer to the question. We even go beyond 1.5 kilometers, which is the observation post in the Cure Valley. So there's a connectivity with the Starlink. It's a direct satellite connectivity with the very capable Philippine Air Force Public Affairs Office. It sits in a military truck, and then it go live stream with the television set inside the observation post, wherein it situates the dignitaries and other visitors for the rocket launch. And yes, we also have it here. The Philippine Space Agency is requiring us to have a data into where should we land. Like for example, it's more like comparable to the drop zones that PhilSA has released for the public whenever there are rocket launches from other countries. So it's like an analogy to that. So we do a simulation for about 10 key points here as to where would the rocket would land. So as what you can see here, so the data is that's below 1.5 kilometers or 1,500 meters, which is really safe for this one. And we overlaid it to the Crow Valley itself with this picture. So you can see here's our simulation, and here's the map of the Crow Valley. And we're really happy that we can assure the safety of the IT communities in the Crow Valley, and also along with the weather condition at that time, which is there's a typhoon coming in, and there are weather disturbances at the time of the week of the launch also. So next is the logistics. We were very thankful for the local government of Manila to lend us the Manila poster in here for the rocket, and of course the Philippine Air Force for letting us go on board the C-130 from Cebu to Clark Air Base, and from Clark Air Base to Cebu using the C-295 aircraft. So logistics is really challenging because you cannot just ride on board the rocket on a commercial ship or a commercial vessel or a passenger aircraft. So we're very happy with the assistance of the Philippine Air Force. So the launch system here, most of the people pay a lot of attention to the rocket because it's the thing that launches, but in reality, the launch system is made up of three key systems: the rocket, the ground system, and the mission control. And they all have to work as one in order to achieve a successful launch. In our case, we combined the mission control and the ground system into one, and we call it the ground support equipment. So here, you can see this is the launch rail. We have our initial design for a launch rail, and this is our launch rail, and here's the final launch rail. So it's an analogy to the launch. We have the launch tower also for orbital rocket launches. So we have also our launch rail. So here, I want to bring this back again. The system controls all the fill and fire procedures from two electrical systems located in the Tala Hybrid Rocket Mobile Launch Controller. So it's our ground support equipment. So the ground support equipment has been created to allow for safe remote operation of a hybrid rocket using nitrous oxide. So the operation includes both the fill and firing of the rocket, and the remote operation decreases the risk of exposure to personnel to off-nominal high-pressure conditions, including the leaks, fire, and explosion. So thus, the remotely actuated equipment greatly enhances the safety of the hardware and personnel during the nitrous oxide fill and dump procedures. So I would show you here we have the processes, the filling of the propellants, which is a high pressure condition. We have purging and dumping of the propellants, in which we can do it in case of off nominal launch condition, wherein the nitrous oxide is needed to be dumped and purged without firing. So we can send the command, which is a flip of a switch in our launch controller. So here we can see the venting, another process before the launch, which is the venting or with that is our determining factor that the propellant loading is already completed. So it's also comparable to the big orbital rocket launches. So here we have the venting of the liquid nitrous oxide. So, and of course, the firing of the rocket, in which it activates the igniter inside the rocket, and then it started its launch sequence. So, of course, I would like also to emphasize the reusability and sustainability, because in our case, in terms of the rocket manufacturing cost and efficiency, the rocket engine is just reusable, and the 3D printed carbon fiber parts can be manufactured in-house again, making it sustainable, cost-effective, and more efficient. I would like to also share this to you, and this is my last slide for this presentation. And I would like to really extend my heartfelt gratitude. These are the sum of the people, if not all, who have really helped us with this. These pictures are very powerful, because without them, we cannot just launch the rocket and be successful with the mission. This is also, I would like also to extend I want to extend a message to all students. Remember that we started it with junior high school students, so it's a testament that the Filipinos can do this one, can do this research project, or can do this research itself with high school students. And I would like to also share this success to different universities, and colleges, and schools, and government agencies, and private entities, and that we can really go step up and do rocket and space technology application research also. And then this is just the beginning of it. I know that this is smaller rocket than the first presenter, but this is the beginning, and we can go to our ultimate goal, to suborbital and orbital rocket launches. And that's my presentation on the rocket launch operation for the Tala hybrid rocket. Thank you so much for listening.
All right, thank you so much, Sir Fred, for that presentation, and of course sharing the story of your team and the Tala hybrid rocket with everyone here today. And once again, congratulations to your team for launching the Tala hybrid rocket. It's truly astonishing what our youth and educators can do in the field of space science. And I'm sure that your students are also honored to have you as a mentor to guide them in their endeavors. And so I'm sure we have a lot of questions for Sir Fred. So let us now proceed to the Q&A session.
So for our first question from Ethan Jacob C. Rosca, do you have any plans to upgrade this into a fully fledged orbital rocket?
Okay, so that's a really good question. With the success of the launch, the possibilities are endless. But for now, because our students are still in their college level, we have students who are upcoming third year and fourth year students. They would like to finish their schooling first before going into or proceeding into the scaling up of the Tala hybrid rocket. So, but for the plans, yes, we also plan to do that. But we're not yet certain of the timeline for that.
All right, thank you. We have another question from Jan Miguel Rejano. Says, good morning. I would like to ask for people who are also interested in making and launching their own small-scale model rockets, what are the steps and which agency should they contact in order to acquire permission to buy, carry, make, and launch a model rocket fuel, such as KNO3 or sugar rocket fuel?
So, thank you for that question. In our case, we also started with that on way back 2017. We have sugar rockets, we have black powder rockets, and all we tested with different rocket propellants. So, and we still have the paramount of safety in that because we're teachers, we're educators, and we need to have the safety for students, especially in private institution. So in terms of the development for that, we really need to operate with the existing agencies for that. We have the Philippine National Police, the barangay, you have the local government unit. So you need to also assure them that the safety of the people are you have to consider that. The Philippine Space Agency, I could really say that the government now is really supportive. Um, right from the start of our rocket development and any other research ventures out. I'm very happy with the Philippine government represented by these agencies also. So yes, in with the permission, these are some of the agencies that could also help. So I hope I answered your question.
Related to that question, I guess. So, really, since rocketry is still young in the Philippines, are there any laws that one individual should be cautious when testing solid propellants? Furthermore, are there any organization for amateur rocketry currently in the country that students and researchers can join? And if there is none, is there any plan to establish one?
Right. So that's also a great question. I'm not sure if I could uh go into the details of it, but I would also like Philippine Space Agency to answer that. But for us also we had some talks with the Philippine Space Agency because we were like the pioneers of the craft. So we had consultation as to how should we do like let's say that the rules and regulations into launching rockets later on, like to have to foresee, especially with the regulations for this one. And I know that the agencies have their own efforts also with regards to this. So um, I'm sure Mr. Matthew and Miko can also attest to that efforts also.
So if I may add, I think there's no current plan for students for this such endeavor right now. But we are currently focusing on small satellite development. So if you're interested on those things, maybe you can.
And I would also like to add, um, with that, to young people and students currently interested in rocketry, as mentioned by Sir Fred and even our speakers before, just keep pursuing your interest there because definitely down the line, this is only the start for the rocket and space flight industry in the Philippines. So who knows? Maybe you might be the person who is leading those that project or those projects in the future. So there's another question also right here in the Q&A tab. It's looking ahead. What are the future plans and prospects for the Tala Hybrid Rocket Program? And are there any follow-up missions or developments that you can share with us?
Yes. Thank you for that. As what I've also mentioned earlier, the possibilities are endless. Are on the fire of these students that we have are really burning, and then they have the spirit to do that. So it doesn't just end there. So the possibility of developing another one, scaling that up, launching it again because that's the rocket and the rocket engine is also reusable. That's a big possibility in the coming years to come.
Right. So another burning question for high school students. What subjects would be relevant as preparation for learning more about rockets?
That's a really good point because I am also teaching high school students. There are so many things that are really connected to doing rockets and to science and math and other subjects. I even have the list of that. For like for example, if like giving the value of doing space technology applications is like the question on what will be the use of the rockets. Like for example, if you have if you know the usefulness of the GPS on your phone, you know how useful are the GPS satellites that we have, and those GPS satellites should have a launch vehicle, and that is now the rocket. So you have like a jeepney in which you need a passenger for that, which is the satellite. In terms of the subjects, in terms of the lessons, I'll give you a one example, which is the Newton's laws of motion, which is I one of the key things that I've shown in your video a while ago is let's say that the third law of motion could be explained really thoroughly in the real world applications, and students could really say that learning is not just inside the classroom. It's beyond the four walls of the classroom. It's really enjoyable if you're not just doing your studies for just extrinsic motivation, meaning you want it for grades and for scores, but you do that intrinsic motivation. So you do this one because you really wanted, you have the passion for this. Mind you, the students that we have in the Tala Hybrid Rocketry team don't have a connection with their subjects. They don't gain extra point for this. They don't have extra grades for this one, and some of their vacation also might be sacrificed just for the making of their passion also for research.
And if I may add, so I think launching rockets is a collective effort. So any degree or field can contribute to rocket launching.
Yes, I agree.
We also have another question. And so going into this endeavor, what are some of the unexpected big challenges that you encountered while you were developing and launching the Tala hybrid rocket?
Yes, we have several challenges, including the technicalities of the rocket, because we really started from zero to hero. Our students have really have to, even they are still in high school, they have to go to engineering level skills to really build the rocket. We teachers have to learn systems engineering, to know how to integrate all the subsystems of the rocket. We have to go through different literatures. We have to go through a lot of like information for this one. Also like the logistics of it, like how would you get the rocket from point A to point B. You have to also to clear with the different government agencies, especially that this building a rocket would have different concerns, especially with it's like it's a dual purpose thing, maybe, so you can also have that for civilian and both for other uses, and we cannot just have the we can let like bad entities to get their hands on with the rocket, because it's really dangerous. So we have to really go into confidentiality stuff. We have to be, our students really know it, even in the verge of social media right now, even with the TikTok and with all the other platforms, that they don't have like the urge of telling it to people that this is what we do, and then you cannot just say to everyone. So that's one thing.
I think that's the end of our Q&A session and the presentations for today. So thank you again, Sir Friend, for accommodating
Thank
us
you so
and
much.
giving the time.
My pleasure and honor.
Thank you. Thank you.
To conclude our webinar, let us hear from Dr. Ariel Berlangco, the Director of Philippine Space Infrastructure Bureau of PhilSA, to give his closing remarks.
Okay, thank you very much, Matthew and Nico. Ladies and gentlemen, excellent speakers, esteemed participants and fellow space enthusiasts. Magandang araw at isang masayang Philippine Space Week po sa ating lahat. What an incredible journey we've embarked upon today in this webinar on rocket launches. From the introduction by Diana Pon about preparatory to Mr. Dong Yun Shin's captivating lecture on the intricacies of orbital and suborbital launch vehicles, and the inspiring account of Mr. Alfredo Padorla Jr. showcasing the triumphs of the Tala hybrid rocket team in the Philippines. These are part and parcel of Yamang Kalawakan or space resources. Through the webinar, we've soared through the limitless expanse of human innovation and exploration. As we approach the conclusion of the SIICaP Lakbay Kalawakan webinar, let us take a moment to reflect on the remarkable insights we've gained in the spirit of collaboration that has brought us together. Dream big, aim high, and never stop exploring. This sentiment resonates deeply with the essence of our discussion today. We've seen how Perigi and the Tala team encapsulates this ethos. The presentations reminded us that the stars are not as distant as they seem when driven by passion and ingenuity. Dong Yun Shin's lecture delved into the technical marvels that power our journeys from our Earth. His elucidation of launch vehicles, particularly the development of the Blue Whale 1, opened our eyes to the intricate valley of physics and engineering that allows us to bridge the gap between Earth and cosmos. Elaborated on small and reliable avionics, the LOX or the LOX compatible carbon fiber tank, and the liquid methane engine. The planned activities in the Philippines are something to look forward to. We are also graced with the inspiring tale of the TAL hybrid rocket team, guided by the expertise of Sir Fred. The story exemplifies the potential that lies within grassroots initiatives, showcasing that innovation knows no bounds. The successful launch of the TAL hybrid rocket in the Philippines is a testament to the power of collaboration, determination, and the pursuit of knowledge. I extend my heartfelt gratitude to Diana, to Yun Shin, and to Sir Fred for their invaluable contributions that have enriched our understanding of rockets and fired us with enthusiasm. I also express my appreciation to all of you, the organizers, our enthusiastic audience, for your unwavering curiosity and engagement. As we conclude, let's carry the spirit of this webinar with us, spirit of collaboration, exploration, and the unyielding belief that humanity's reach will forever exceed its grasp. Maraming salamat po at muli magandang araw o magandang umaga sa ating lahat.
Thank you, Dr. Ariel, for that closing remarks. So before we send our evaluation and close the program, may I request a photo opportunity again with the speakers and after that, with our audiences as well. So if Miss Diana and Mr. Shin still here, I request to open
Sorry,
the
Mr.
cameras.
Shen had to leave for work, but I'm still here.
All right. Thank you, Miss Diana.
Take the photo.
Thank you, Rita.
1, 2. Another one. Okay. 1, 2. You.
So right now we can invite also the attendees. So audience, if you can open your account, please do so. Right. Salat. Is it okay now, Ida?
Let's just wait for a few more seconds. Your cameras. That's it. Your smiles, I'll be taking now. 2, 1. More time. On. Very much.
All right. So before that, we also have some few announcement. You know what? You can share this screen.
All right, so before we send the link to the evaluation form, we have some few announcements as mentioned by Nico. So celebrate the Space Week, so Philippine Space Week with us with our remaining programs and showcases. So we'll just go through them before we end the webinar.
Uh, we are inviting you to the Yamang Kalawakan selfie or groupie challenge. So take a selfie with your favorite space technology and win up to 5,000 pesos. Please check our Facebook page to see the details.
And this afternoon, we actually have another event. So we're also inviting you to the PAPGAPI PAN Philippines project launch and webinar at 2 p.m. PhilSA is partnering with another Korean entity, so KOICA, to strengthen national capacity to monitor and improve air quality and policies in the country.
After that, we also have the Advancing Core Competencies and Expertise in Space Studies or Access Nanosat webinar at 4 p.m. The webinar will delve into the team's perspective on developing the country's first 2U satellite, the Mayat 7.
And on top of that, we are also calling on our citizen scientists to join the Pinas Citizen Science Network in collecting field data. So please join us on the launch and hear how you can make an impact through field data collection.
That ends our webinar for today. Please stay tuned for our last part of this webinar series. Thank you for joining the mission. Please continue following PhilSA journey. Visit our website and social media pages for updates. Happy Philippine Space Week and have a good rest of the day.
Thank you, everyone. Thank you to our speakers for joining us today.